everyone, and welcome back. My name is Mr. Cobalt, and in this video, I'm going to be talking about the solubility product constant, KSP, and precipitation. So let's get into this. So we talked about the solubility product constant, KSP, in earlier videos, and so how does that relate to precipitation? So we've talked about how things are insoluble or soluble, and then how there's a degree of solubility, and how we can use KSP to understand the solubility of some sort of ionic substance. But what about precipitation? So we're going to have to go back to our Q value, our reaction quotient. So let's go back to that and then talk about how that relates to KSP. So here I have calcium fluoride solid that is going to dissolve into calcium and fluoride ions like so, and we have equilibrium. So if you remember the quotient here, the reaction quotient is for this reaction going to be the concentration of your cation, your calcium, multiplied by the concentration of your fluoride ion raised to the power, the coefficient as a power, so the power 2 here. So basically, if you remember, your reaction quotient Q is exactly the same formula as your equilibrium constant. In this case, we're talking about the solubility product constant for dissolving reactions, right? So these are exactly the same formula. The only difference between these two is that the KSP formula is the value only at equilibrium. So this only gives us the value at equilibrium. So here we would need to know what the equilibrium concentrations of our calcium and our fluoride ions are, right? Without those, we can't calculate KSP. However, your quotient, that's the value under any condition. So we can calculate the quotient given any concentrations of these two. So if we know the concentrations of calcium and fluoride ion in our solution, we can go ahead and use that to calculate Q and then compare that to the KSP, right? So then what does that tell us? So if you remember, the relationship or the comparison between Q and KSP will tell us on what side of the equilibrium the reaction is at. So in this case, we're talking about dissolution. So if our concentrations are more on this side, right? If Q, for example, if Q is larger, right, larger than KSP, then that means that we have way more, how do I say this? Way more ions in solution than we would need for equilibrium. So we have way too much. So that would be more like having a supersaturated solution where you have more ions that are dissolved than you would need at equilibrium, right? And so if we kind of remember what's going on when you dissolve, right? You throw something in, you throw a solid ionic substance in water, like say salt, NaCl, you throw it in water, you mix it up, and it dissolves, right? And you keep throwing salt in there, and it dissolves more, right? Can you do that indefinitely? No. At some point, it's going to be saturated to the point where you can't dissolve any more salt in your water because it's reached its limit. It's now at an equilibrium, right? So here we're looking at the equilibrium. So going back to the relationship between Q and KSP, right? So here, if Q is smaller than KSP, right? Smaller means that these values are less than what you would have at KSP, right? For KSP, you got a certain amount, right? So these two are less than this. So this value Q means you don't have enough of your ions dissolved in water. So that would be an unsaturated solution. So that means that it's going to have to shift to make these larger, right? So if your Q value is smaller, then that means that these are too small. You don't have enough of these in solution. So you got to increase your ions in solution in order to reach the value of KSP. So that means you're going to have to go this way. You're going to have to shift towards the products, the right side. So here it's going to shift to dissolve more solid. So when you throw solid in there, it's going to dissolve, right? So that would be if your Q value is less than your KSP. If your Q value is equal to your KSP, that means you're at equilibrium, you're saturated. Adding more solid is not going to dissolve. The solid you add, if you add more solid, it's not going to dissolve because it's already saturated and it's at equilibrium. And then if your Q value is too large, that means that for these you have too much of the ions in solution, and so you're going to have to get rid of them, right? So you would have to be in a supersaturated solution, and for a supersaturated solution, those ions can indefinitely stay in solution unless, of course, you disturb the system somehow. So if you shake it, or if you add a seed crystal, if you drop a crystal inside there, that'll disrupt and it'll start to form crystals where the excess ions that are in solution will then form a solid. It'll precipitate out and form a solid. Okay? So that's what the comparison of Q, your reaction quotient, and your KSP means. Now, one question you might want to answer is, what if I throw two things into my solution? If I have two solutions, I mix them together, will a precipitate form? We've learned how to answer that question earlier when you're using your solubility rules, right? So you add these two substances together, and you figure out, okay, well, what products are going to form? You figure out, excuse me. Sorry, light went out. So you figure out, okay, so I'm giving these two ionic substances. I put the two inner ions together and I write that product down. And then I put the two outer ions together and I write that product down. And then I say, okay, well, are either of these two products going to precipitate out? Am I going to get a solid? And so you can answer that question by calculating the Q value and comparing it to the KSP. So here's an example. So I have my silver nitrate, and that's going to mix with my potassium iodide. So I have my two beakers. I have a beaker of my sodium nitrate, and I have a beaker of my potassium iodide. So here I mix them together. My potassium iodide has a 0.010 molarity, and my potassium iodide has a 0.015 molarity. So that's the concentration of the ions. So when I mix them together, I want to know, am I going to form a precipitate? So first, I need to write down what my products are. So remember the two inner ions to go together, so the potassium and the nitrate, and I write KNO3 plus, and then the two outer ions together, silver and iodide, so that's going to go together, so I get AgI, and I balance the charge, so the formulas are balanced, so potassium has a +1 charge, nitrate has a -1, so 1 each, and same with silver. So silver has a +1, iodide has a -1. So here are my two products. And so now I want to know, is there a precipitate going to form? Well, I know from my solubility rules that nitrates are not going to be soluble, so they're going to be, it's not going to be insoluble, it's going to be soluble, so no precipitate's going to form from here. But my silver iodide can form a precipitate. So my solubility rules would tell me that this is insoluble, and therefore would form a precipitate. But will it, right? So it's only going to form a precipitate if I have enough ions in solution. So I need to figure out what my Q value is. So my quotient for this reaction is going to be my concentration of silver plus ions multiplied by the concentration of my iodide ions. And I want to plug in those concentrations. So I have the concentration. So my silver concentration from my silver nitrate is 0.010 molar. So that's going to be equal to 0.010 molar. And my iodide concentration comes from my potassium iodide. So that's 0.015 molar. So I'm going to write that in, 0.015 molar. Oops. And when I calculate that out, I get that's going to be equal to 1.5 times 10 to the negative 4. Now that's my Q. Now look at KSP. My Q is much, much larger than my KSP. So what does that tell me? Q is much larger than KSP. That means that I am going to have a precipitate form because my concentration of these ions are so much greater than what I would have at equilibrium. I have too many ions in solution compared to what I would have at equilibrium because my Q value is much larger than KSP, so it will precipitate out. And so that's how you can figure out whether a precipitation is going to actually occur. So it is going to depend on the amount of ions in solution. So at this point, now we can determine whether or not really you will have a precipitate given certain concentrations of your ions. Okay, so I hope this video was helpful. I hope you learned and enjoyed from this video. I hope this clarified things for you. And if it did, please like my video. Hit that like button right there. Also, subscribe to my channel. Hit that notification bell right up there so you can be notified by other videos that I put out. Also, make sure you put a comment in the comment section. Leave me a question, a comment, whatever. I love to hear from you. Thanks for joining me. Have a great day.